Yeah, I've been around in Bitcoin for about 2012. Originally as a hobbyist, then I kind of committed full-time around 2015. Started Bitcoin, CommerceBlock around 2016. From a technical background, so a lot of the work I did was very much technology-based, but really now I'm kind of like doing more stuff with clients around, Fortune 500 companies, trying to get them into using public blockchains. So.
Cool. Okay. Yeah. Okay. So shall we
introduce yourself?
Okay. Yeah. Okay. My name's Tom, and I'm CTO at CommerceBlock, and I've been working with Nick now since the start of this year. I've been working full time in the cryptocurrency space since 2016. I used to work for a company called Enchain, which you may or may not have heard of.
He didn't believe in Satoshi's vision.
No, but yeah, it was all good, clean fun. So yeah. So Nick, do you want to maybe talk a bit about the company history?
Yeah, so as I said, we were originally based in New York, and one of the challenges of doing a crypto startup in New York is the bit license, which made it virtually impossible to do a Bitcoin startup unless you had considerable amounts of money. But where there's a negative, there's a positive. It basically had a booming OTC market. So I basically worked with some people I knew around the OTC space, building kind of like boutique OTC software. And one of the first challenges I noticed around OTC is, you have this wonderful decentralized currency, but the moment you want to do an OTC trade, you're back to using an escrow or a trusted intermediary. So we looked at something called pay-to-contract, which is, at a very high level, a way of embedding an invoice, a contract, into a Bitcoin address. And then once you complete that address, you can kind of link the invoice and the contract to the address. And so if I want to do an OTC deal with, Tom, I can basically give him an address, which basically has the kind of the OTC deals, the invoice, the receipt, and we have a kind of like a cryptographic history. And if he was then to send me the Bitcoin, I can only release the funds with the actual original invoice. And that became quite popular, and we found quite a lot of use cases from that. And we ended up making that into a BIP 175. And then 2017 happened. And I guess, although it was mainly remembered for the ICO boom, a lot of institutional companies or Fortune 500 companies were willing to talk to people like me, which they weren't a few years ago. Bear in mind, I came from a banking background, but whenever I said the word Bitcoin, I was accused of being a drug dealer or worse. And, I met Danny Masters from Global Advisors then. And, Danny came from a commodities background. And, we discussed how we could get commodities traded. Now, to be fair, this is 2017 where, anyone doing any form of asset is talking Ethereum, EOS, Tezos, something, blockchain 3.0. So for them to invest in us, which we were still pushing, Bitcoin as a kind of like Bitcoin nationalist, was quite brave on their side. So but since then we've done a lot of projects, and we'll talk about them.
So yeah, this kind of summarizes some of the kind of markets that we're interested in, the kind of things we're going to focus on: fund management, commodities. Really, we have a client now that we're building a tokenized commodities platform for them. And other things. Maybe Nick, you're probably best to.
So approaches. So I have a bit of a history in coloured coin and mainly coloured coins. They were interesting. I think they were popped around 2013. But the issue, and they've been mildly successful. Tether, which is probably one of the most successful altcoin, is based on a coloured coin. But you have perverse kind of like incentives. You have that issue where a one Satoshi transaction could have a value of X amount of Tether, and you never know how the miners can cooperate. And then you have public blockchains. I tell you, having spent a few years working with Fortune 500 companies trying to get them into crypto, they're very nervous on using a public blockchain. It's very hard to say to a CEO of a company that your commodity or your security is potentially disrupted by CryptoKitties or some sort of proof-of-stake issue that EOS may have. And you have an issue there where, you can't even get insurance for this kind of stuff. You can't get custodial. It doesn't work. So a lot of the people I've spoken to, they've invested money on blockchain projects based around R3 and Hyperledger. And really what they've found out is they've spent a lot of money on an expensive database. Yeah, probably a bad database because you don't have all the query functionality of a database. And we believe we've got a solution kind of in the middle where we solve the issue of us not being a bad database. But also we have the value of like Bitcoin. We can use its proof of work. So our approach is very much based on sidechains. Now, there are multiple approaches to sidechains. Now, people always try and compare them, like which is better, but they actually all have different trust models. Maybe
Yeah. Okay. So, I mean, so of the kind of sidechain ecosystem as it is at the moment, I mean, we have these projects like Blockstream's Liquid. There's the Rootstock sidechain and this new drive chain idea. So these sidechains have basically different kind of trust models. So Liquid is what's called like a federated sidechain. So you actually have a fixed set of block signers or people that can produce blocks. But the trust is separated out amongst many different parties. RSK is mined to a certain extent, but also has some trusted elements as well. But essentially, what you're doing with a sidechain is with these sidechain projects is that you're kind of outsourcing your the trust basically to maintain the blockchain. So this is very different from a fully public blockchain where you have you're completely decentralized, completely distributed. So sidechains are much more efficient, much faster, but do involve basically, kind of relying on third parties for basically operating the sidechain, producing blocks. And so if you're an asset issuer, so if you want to tokenize some asset or security on the blockchain, you have this additional layer of trust, which, as Nick says, I mean, you need to have someone to sue essentially if things goes wrong. So I don't know if you want to.
Yeah, so essentially what we propose is a permission blockchain. Now, we have our own name called Ocean. It's based off the Bitcoin code base. So essentially we forked Elements. So Elements is about 99.5% of Bitcoin code. We're a copy of Elements and we've enhanced it to have our own wallet, to have our own node. Critically, we want KYC. And, we've kind of modularized it. The fact that we're using Bitcoin means that it's kind of well tested. You often hear that Bitcoin's 10 years old. I try and think of Bitcoin of having 10 years of engineering. It's got 10 years of DDoS attacks. It's got 10 years of everything thrown at it. I mean, it's been dead 120 times or something. Whereas these new white papers, I mean, they're not tested. There's a huge challenge in pushing a blockchain that's had not the kind of like the heavy-duty war that Bitcoin has had. So essentially, we're open source. It's called Ocean. And we basically use our MainStay protocol to basically attest it to the Bitcoin network. Originally, we were going to do some sort of timestamping, but I think we realized that there were challenges there. So if we go on about MainStay. So MainStay was basically based on a timestamping approach where we wanted to use bit 175. So as I said previously, bit 175 doesn't leave a trace on the network. So we were able to attest to the Bitcoin network with no traces. However, there are challenges there in that you could basically attest, say, every other block, but if you don't have the relationship between the blocks, you basically could have you could have mutability in between. It's very much based on an idea called a single-use seal, which is an idea created by Peter Todd, which he kind of referenced a few in his blog sites. We plan to be live with this in next month or maybe January. It'll be on MainStay XYZ, and it's going to be a service which people can use to do kind of like attestations to the Bitcoin network.
Bitcoin, its heart is a way of using economic incentives and proof of work to create a global consensus on the order of transactions happening. And this is a really kind of revolutionary thing that you can reach a global consensus on the order of things happening without relying on any trusted third parties at all. And basically, you have a real world cost to basically try and reorder things or try and rewrite history. So it's about having a single history that the entire globe reaches consensus on, and that cannot be tampered with, cannot be reversed. So Bitcoin basically drives us towards a kind of global consensus. And if someone was to try and create an alternative history, they basically have to spend real money in order to do that. So if you wanted to go back 10 blocks in Bitcoin and rewrite those 10 blocks, it would cost you over $1 million. Maybe a bit less today, but okay. But it's still, there's a cryptographically provable real-world cost to rewriting the history, and it's kind of one of the fundamental value it gives. So because it has this property, as well as creating this system of hard, incorruptible money, it also gives us the ability to actually trustlessly timestamp things. So we can actually prove that something existed in the past without relying on any third parties. So the way this typically works is you take some piece of information, a document that you want to prove existed at a certain time, you hash it, and then you include that hash embedded somehow in a Bitcoin transaction. Then you can go back and prove to anybody that this piece of information existed at this point. So although this is a proof of something existing, it's not a proof that other things didn't exist. It doesn't tell you anything about the provenance of that piece of information or how exclusive that is. To give an example, I could timestamp a document at one point in time, prove that document existed at some point in time, but I could also timestamp some other documents and basically give you the proof to you the timestamp of the document I chose after the fact. So if we kind of imagine what this would be like for a sidechain, we could take our sidechain and we could take the hash of each block and timestamp it into Bitcoin. But this doesn't actually prove that the sidechain is immutable. So I could, fork my sidechain if this was a sidechain with a fixed set of block creators. We could all collude together and create a fork of this sidechain, and also timestamp that fork into the sidechain, and then provide you with the proofs that this fork existed. So I could essentially give one set of people one set of proofs and another set of people another set of proofs, and double spend, essentially. So in this way, doing just a straight timestamp basically doesn't prove anything about the immutability of that sidechain. It just proves that a single state existed. So the one thing that we can do in Bitcoin, so it's essentially what we're talking about is proving a negative, which in the real world is impossible. But the whole point of the Bitcoin blockchain is that you can prove a negative. It prevents double spends because you validate everything. So no single output can be spent twice. So this then gives us like this proof of a single history and proof of immutability. So we exploit this then in this MainStay concept. So what we do is we create a chain of transactions that can only have one output. So we have an unbroken chain of transactions on the Bitcoin blockchain that cannot be forked. And essentially we bind this directly to a sidechain. So in order that you cannot, after the fact, change the sidechain history, so we do it like a two-way link. So we take a transaction in Bitcoin and we actually commit that transaction ID into the genesis block of a sidechain, and then can generate sidechain blocks. And then periodically, we then commit the state of that sidechain back into the Bitcoin blockchain in this single chain of transactions, which we call the stay chain. So by doing this, every time we do a commitment back into Bitcoin, we basically prove the immutability of the sidechain, and that the sidechain cannot have two histories. And so it's as immutable as Bitcoin. Then it would cost the same amount of money to go back and rewrite the history of the sidechain. So, and we keep doing this periodically as the sidechain propagates. And really this gives us basically the same immutability as Bitcoin. But we can have basically a sidechain that is much more scalable, much more modular, much more basically customizable, and also we can control the permissions of this sidechain. So really what we're doing with this is we're taking, Bitcoin has basically two revolutionary properties that's kind of given to the world. One is censorship resistance, and the other one is immutability. So we're taking one of those properties and basically kind of extracting it from the blockchain and adding it to a permissioned sidechain. Nick, I don't know if you want to...
So essentially, the way we run the sidechain service is we have like one instance, and we basically give basically 250 slots per MainStay. Anybody can join in. They have to basically work out an agreement with us, and they basically get one of these slots. And we attest, I think, once a block, or yeah, we haven't figured it out really. And essentially, we have 250 slots on our sidechain server. One sidechain would be essentially one slot, but we're also having people come to us with different ideas. We have people wanting to do document management. We have people wanting to do, what did you want to do? Voting, for example. I mean, we never really thought about this. We originally just wanted to do this for sidechains, but we're getting a lot of people with different use cases coming to us. We even had someone 2 weeks ago that wanted to build a custodial solution, but wanted to kind of attest, their funds on the Bitcoin blockchain, and they wanted to be one of these slots.
So yeah, okay, yeah. So this makes the whole thing kind of quite extensible. That we can get high efficiency, because one of the key things with this MainStay concept and protocol is that you don't have to ask any permission from Bitcoin miners. So some people have actually compared it to like merge mining, but with merge mining you need to get the Bitcoin miners to cooperate. With this you don't. You just need the ability to send Bitcoin transactions. But the thing you do have to do is you have to pay for the Bitcoin transaction fees. Sometimes that's probably not much money. Maybe if we hopefully have a huge bull run, maybe transaction fees on Bitcoin will go very high, in which case this would be very expensive to run. Which is why having this kind of this collective, this connector protocol, we call it, where we condense all the transactions in Merkle tree, we can spread the cost basically. And we're planning to operate it at cost for the time being, because it's open source. Obviously, anyone can use our code.
For hardware, we basically have a deal where we're preferred partner Securasys. So they're an HSM provider. They've allowed us to kind of like write custom software. So for MainStay, they'll be providing it basically more or less at cost price for the next 2 years. And we'll be using also Securasys to secure our sidechains. So just like you may have heard that how Blockstream have kind of dedicated hardware for their signing nodes, we also have like kind of bespoke hardware. It's done in partnership with Securasys, and we have we are a preferred vendor of theirs, and so that means we have access to their APIs. We can build specific software for blockchains. Predominantly, we're doing some stuff for the MainStay as well, so that kind of gives us a level of security. It tends to be hosted in Switzerland. People like that for many reasons, but it kind of works for a lot of our clients that we can host this stuff in Switzerland. We're outside a lot of jurisdictions, etc.
That's basically one of our key projects, our key kind of technologies is this MainStay. The second one is this, what we've called covalence. And it's another layer of security that we can add on top of these permissioned sidechains. In order to increase the resilience, increase the security of the network. Essentially, we want to create this kind of sharing economy based on a token model, so that we can incentivize people to work for the network. And we kind of want to base this on a kind of model we take inspiration from, like, say, Airbnb and kind of Uber models, where you have a centrally managed but decentralized network that's governed by what we call like the network token.
Yeah, I mean, one example is if you look at what happened last year, a bunch of miners and a bunch of exchanges got together in a hotel room in New York and decided to change the network. It didn't happen because why? Because you had nodes running around the world for Bitcoin that refused it, and that's where UASF happened. We have the same problem. Because we're a sidechain, we could basically have a successful precious metal token. It's fairly centralized because, the moment you start doing securities or gold, you are centralized. So if it's only on a few exchanges, they could get together and collude. How do you stop that? Well, you want nodes to be run. Now, Bitcoin has a unique concept in that, it's very libertarian, that there's no leadership. You have many people incentivized to run nodes. We won't have that. So what we propose is kind of like a token model where we incentivize people to run nodes. So essentially, if you're a gold token on our platform, you own the hardware. You can use our network where you give a cut of your transaction fee and you incentivize people to run a node. So essentially anyone with a bit of Unix skill, or, I mean, we've done most of the work so people don't even need to know Unix. They can do it from AWS. They can run a node. And what you're doing is you're providing security for this asset. So, and this will be fully public. So if someone wants to run 2 nodes around the world, as opposed to another guy running 10,000, it kind of gives you, an idea of how secure. And these nodes are basically, they're like watchers, they're policemen. They're reporting for any, double spends. They're reporting for like reordering of transactions. They're providing another layer of security, which I think is kind of key for these sidechains, because a lot of these sidechains are based on trust. If you have independent nodes running, watching these sidechains, I think it gives another level of trust. And it's going to be, because these are permission public chains, anybody can see which nodes are running, how many are running, how much of the transaction fees are being issued. It's kind of very transparent.
Yeah, okay, so this kind of leading on to that, this kind of architecture that you have basically a network of permission sidechains, where each of these sidechains is managed and controlled by an issuer, yet they use network services provided by this kind of service chain. And this kind of service chain basically coordinates the work that people do for these asset-backed or security-backed sidechains. And so we believe that this is a model which should increase basically the network effects, increase the security of the network, and increase the value of the network as people are incentivized to offer their services, and in return, earn some money. So
So we want to engage with the community. We're fully open source. The only things that aren't open source are I think the software we write for HSMs for obvious reasons. Also, I think we plan to have more kind of like custom UIs, because at the moment the issue with building sidechains is a lot of manual coding. We want to make that more, right-click, create asset, set inflation rate, etc. I think that software would probably be not open source, but anything that runs live in production is. And we basically want to engage the community, but we want people. We want to pay people. We want to pay people to run our nodes, get a cut of the transaction fee, and that transaction fee is decided by our clients. So if we will make it as easy as possible. We already have the bindings already for AWS. We're planning to do some stuff around Google Cloud as well, and that's the whole approach. We want to incentivize people to run nodes to secure assets which are running on top of our sidechains. When I say our sidechains as well, we don't own the hardware. We basically provide the tooling to build these sidechains. These sidechains are owned by our clients, so there's no kind of custodial risk on our side. We're not a blocker to companies, basically, whatever they decide to do. But that's it. If you've got any questions, fire away. Well, the reason it can't be open source is because we have to use a third-party library from Securasys. So unless that third-party library is open source, I mean, we can't necessarily make that open source because. Well, you're trusting Securasys, so I mean, and again, we don't force people to use Securasys HSMs. We have a preferred, relationship with them. If you wanted to use, I don't know, Amazon Cloud HSMs, that's your call. It's just that we have Securasys are small enough where we can talk to them directly and get to know their hardware. I mean, I don't think Amazon would probably talk to us much. So that's the kind of relationship we have.
Oh, okay. But yeah, so essentially we're depending on our frequency. So we're going to run this service. It's going to have 250 slots, but only one commitment. And how frequently we do it, we're thinking initially like once an hour. But if people are going to rely on this Bitcoin backup confirmation to to consider their transaction on the sidechain confirmed, you want to have this done regularly. But at most, it's going to be one transaction every one block or so. So yeah, I guess. So it's going to be. Yeah, which would be a second transaction. But in terms of the actual, kind of burden on the Bitcoin blockchain, we're talking just a standard, one input, one output transaction. It's a couple of 100 bytes.
I guess I've always I have a history in Bitcoin where I spend a lot of time with colored coins. I always like the idea of having assets on a global blockchain, and I guess having spent a lot of time in Bitcoin Core, I kind of realized that it would never scale to have this kind of one blockchain which have every assets. It's a bit like trying to put every website on one web server. So I like the idea of having side chains, and I also think assets are centralized. We have some customers in the precious metals space. The moment you have precious metals in a vault, it's centralized. But they can own the side chain, but then you can use all these kind of like public tools like Bitcoin or incentivized with nodes. So I wouldn't say you have decentralization, but what you have is transparency. And decentralization is probably an overused word in Bitcoin and blockchains. It's more about transparency. It's more about seeing what's happening and trusting the asset because you know that they have 1 ton of gold in the vault, but not 5 tons, but only 1 ton. So that's what we provide, and I think there's a real use case there.
Yeah. Also, I think really it's about what you can offer with such a system like this is proof of ownership. So you can prove that you own the asset. You can prove that you own whatever that token represents without trusting the asset issuer to keep that record for you. So you can independently prove your ownership of something.
Which the way to think of MainStay is you're kind of selling time. I mean, it's probably Bitcoin's a great time machine in that you can put something 10 years, 5 years back. It's permanently locked in there. So we're able to maintain like a kind of like a state machine of time over the Bitcoin life cycle. And so long as Bitcoin exists, we're fine. And we're not tied to Bitcoin. If SV takes over or whatever, we could quickly move to them or Dogecoin or whatever. But we're kind of getting that history of time. Well, we do have confidential assets. To be honest, most of our clients don't want to use it, but it's an option. I mean, Tom could probably explain about confidential assets.
Yeah, I mean the particular clients we have at the moment didn't want confidential transactions, but we copied over. We forked the entire Elements code base, so it's all in there. We did initially come up with a scheme when we were thinking about implementing this, and we may do in the future for different clients, that essentially we'd have a kind of new transaction format. When someone would send a transaction, they would have to essentially send their blinding key to the asset issuer, so that the blockchain itself would be completely confidential and all the values would be encrypted. But the asset issuer would have a database where they could selectively, unblind the amounts in order to, stay compliant with regulators, which would obviously need to keep that history, that record. But then to other verifiers, you could publicly verify the chain, but people wouldn't be able to see any of the amounts, and so you could avoid like front running and things, which is what they want to achieve with Liquid. So. So, with a permission sidechain with a federation, you can generate blocks very fast and very regularly. So, we do it every 1 minute. We generate a new block. On Bitcoin, you have very irregular block times because of the nature of proof of work. You can have one in 20 seconds, or you could wait half an hour before you get your next block. So there's going to be some latency in your confirmation. So you can get lots of sidechain confirmations that your transaction's included in a block, but you may have to wait some time before that's included into Bitcoin. And there will be there won't be a huge reliability there, because obviously, and again, if the fee market became very prohibitive, you might have some outages there, because basically your transaction wasn't included, or your commitment from the sidechain wasn't mined very quickly, for example. And so the user experience for this is going to be pretty much like 2 levels of confirmation. So your transaction will be confirmed by the sidechain block signers, and then later on, maybe half an hour, an hour later, you would then get like a secondary confirmation that it's now trustlessly attested to Bitcoin. But so we don't need to attest to every block. As soon as you've attested to one block, all of the previous sidechain blocks then become immutable because they're linked in a hash chain. So essentially, you need just the first commitment from the base of the, what we call it, the stay chain, into the side chain, and then the latest commitment basically then proves the immutability of the entire side chain to that point.